Hey guys, I'm gonna do a video for number 2 and number 12. Alright, so these are important because they're using everything that we've learned about imaginary and complex numbers and applying them to how we utilize those skills with the quadratic formula or completing the square if that's how you choose to solve these. So let's start off with number 2. Number 2 is already in standard form. You see we have our ax squared minus or plus bx plus c. So we can take that and put it right now into the quadratic formula. So we'll do that. So we've got our negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Remember, we don't ever want to drop this fraction bar and forget that it's also beneath the negative b. All right, and our next step, we're going to simplify a couple things. Negative 4 is just 4, so that's easy. Negative 4 squared is 16, and negative 4 times 1 times 9 is negative 36. So 16 minus 36 over 2. Next move, 4 stays the same. 16 minus 36 is going to be negative 20. So we have a negative under a square root now. That tips us off we're going to have an imaginary number here because we can't remove a negative without using imaginary numbers from a square root. So off to the side, I'm just going to kind of rewrite this square root. The square root of negative 20 is the same as, remember we want a perfect square. So the square root of 4 is definitely something we're going to be able to remove. We're going to still have left the square root of 5 after we pull the square root of 4 out, but we also have to recall that 4 times 5 is 20, so we need a negative 1 to make that a negative 20. The reason we have to multiply by those three things is because the square root of 4 reduces to 2, radical 5 stays the way it is, square root of negative 1 is I, which we will rearrange to 2I square root of 5. All right, so that's going to be our next step. We now have 4 plus or minus 2I radical 5 over 2. And I'm going to simplify that by dividing 4 by 2 and also by dividing 2I radical 5 over 2. I can only simplify this if I divide both of those two terms by 2, which is going to leave me with 2, because 4 divided by 2 is 2, plus or minus, and 2I radical 5 divided by 2 is just 1I radical 5. So the answer here is going to be 1. Now let's head over to number 12. Number 12 needs us to solve this equation and express it in terms of I. The problem is we can't solve it yet because it's not in standard form. So we have to remember that instead of it looking like x squared minus 4x equals negative 10, we have to add 10 to both sides so that we will have x squared minus 4x plus 10. And now that it equals 0, it's in standard form. We've got our a, our b, and our c, so let's go ahead and throw that into our quadratic formula. And once we've set it up that way, we can just start to simplify. We're going to have 4 plus or minus the square root of 16 again, minus 40 over 2. 16 minus 40 is 24. So let's figure out which perfect squares go into 24. Well, we can break that down as, this should be negative 24. We can break this down as the square root of 4 times the square root of 6 times the square root of negative 1. Square root of 4 is 2. Square root of 6 is still just the square root of 6, but the square root of negative 1 turns into I, so we would rewrite this as 2I radical 6. And that's what we'll do in our next step. So we have 4 plus or minus 2i radical 6 over 2. And much like the last problem, we're going to do that same type of division. 4 divided by 2 is 2. 2i radical 6 divided by 2 is just I radical 6. And it says to express the roots in terms of I, so let's just make sure that we write our two separate roots. We have 2 plus I radical 6, and we have 2 minus I radical 6. And those are your roots. Good luck on the rest of it, you guys. I'll see you tomorrow.